Okay, let's look at a specific way that the Math Excel program wants answers to be expressed to some of these exponential equations. They say solve the exponential equation, express the solution in terms of natural logarithms, then use a calculator to obtain decimal approximation. So when you look at this problem, okay, we have an exponential equation with a variable in the exponential level. Sometimes we would look to see if these two numbers can be written as powers of the same base, okay? But 7 can only be written as 7 to the first power, and 326 can't be written as a power of 7. So that's pretty much off the board at this point. So we're going to have to use a logarithm to solve this. Okay, now, considering we have the ability of the TI Inspire or Desmos to compute logarithms of any base, normally what I would recommend when solving a problem like this is using a logarithm, and I'm going to make this a little bigger because it's probably a little hard to see. Normally what I would recommend is taking a logarithm of each side that has a base that matches the base of the variable exponent. So in other words, if I was solving this problem with the technological tools that we have, I would say let's do log base 7. Okay? Because if I do that, when the x minus 2 comes down in front, what's log base 7 of 7? That's 1, right? So that whole logarithm disappears, and I can come up with an answer to this, a decimal approximation for that, okay? And then just add 2 to the other side to get your solution, right? So that would be the method we would take if we were doing this without this restriction. Now, so again, what would we get here? We can do this real quick. We got time, right? So we could type in, I think, hide that, log base 7 of 326. We get let's call that 2.973. Okay, so we get 2.973 for this answer, and then we would just add 2 to the other side. So 4.973. This is what we would do given the abilities of the technology that we have. Okay, now what Math Excel is asking us to do is take this equation and write it in terms of natural logarithms. So they're saying you can't use log base 7, use log base e. So let's take the natural log of both sides. Now, that doesn't stop us from moving this x minus 2 down in front. We can still do that, right? Because when we take the logarithm of both sides, any exponent comes down in front. We might want to make sure we still keep the parentheses around that. Now I'm going to write this as log base 7. I'm not going to get decimal approximations for these just yet. As long as you recognize that the natural log of 7 is the log base e of 7, and e is not a variable, so this has a decimal approximation, right? It's probably a little bit less than 2 is my guess, but I'm not quite exactly sure, but there is a decimal for this. Okay, so this represents a number. This is not a variable. Now, if I had, pause for a second, if I had an equation that looked like this, I'll just throw a couple of numbers out there. Okay, and I said solve for x, right? The only reason I'm showing you this is to say, well, what would you do here, right? Well, since we're multiplying 4 times this, we can divide by 4. Then we'd have a statement that says x minus 2 equals 7 over 4, and then we'd add 2 to both sides here. We get x equals 7/4 plus 2, whatever that ends up being, right? Same approach to this problem. We just have to move the natural log of 7 as one unit. We're not going to divide this by 7. Once a number goes, quote unquote, inside the log, it's untouchable. Okay? This logarithmic package represents a singular number. So what I can do is I can divide by that natural log. Okay? Again, the reason I'm doing this is because it represents a number. So I'm moving that whole package together. So now we have x minus 2 equals the natural log of 326 over the natural log of 7. And something else to keep in mind here, okay? These numbers can't be reduced separately, and natural logs can't be canceled, even though you want to look at this and be like, oh, I can cancel this because it's one on top of the other. That's not how this math works out, okay? The logarithmic package has to be taken as a single value, this entire piece, okay? So now from here, to express my answer in terms of natural logarithms, I'm just going to leave this. So looking at this is akin to seeing a fraction like so, right? What do? We add 2 and we add 2. Now, when I add 2 to this, I can't actually add 2 to either one of these numbers. Again, for the umpteenth time in this video, these numbers are untouchable. So I'm not going to add 2 to this. I'm not going to try to find a common denominator where I can add this to this. I'm just going to leave this ratio of natural logarithms and put a plus 2 after it. So this would be our expression for the answer. And let's go to Desmos just to see how close we actually were. If we do the natural log of 326 over the natural log of 7 plus 2, okay, right? So this was our answer from before, right? So we can see that those two values actually do match up. Right, so writing it in terms of a logarithm, just keep in mind that logarithmic packages have to move as one piece, okay? The only thing we might be able to do is, expand this or condense it, but we're not looking to do that. We're just looking to represent this as one value, okay? And then add a value to it just by showing that addition.